Arizona State University Bose Center for Law and Society is located at 111 East Taylor Street in downtown Phoenix. Fun facility facts you may want to know about this building. The center is expected to use 37% less energy than similar standard buildings. The cement used contained 50% recycled material. Where possible, 90% recycled structural steel was used. Daylight LED lighting and occupancy sensors used will reduce power density by 10 to 15%, and over 500 low-energy active chilled beams were used to keep the building office environments feeling fresh and comfortable. The structural analysis of the building shows how the system transfers loads through interconnected structural components or members through the building framing and columns. Because of the size of this building, several structural components were used. First and most obvious is the 30-foot V-shaped column as shown in the image in the middle. This column supports the northwest corner of the building while creating an inviting entrance. The benefit of the V-shaped column is its ability to support the load at two different points with one column. Another obvious structural component to this building is the hanging bridge system. Each bridge is suspended from hangers with anchorage points and were designed to enhance the architectural expression of the building. These bridges serve as a connection between the east and west buildings, which encourage interaction between departments. Each bridge also includes overhead metal beams which help secure the bridge in place and act as stiffening trusses. The mechanical analysis of the building includes some electrical boxes and also shows the design of heating, ventilation, air conditioning, and refrigeration throughout the building. The center is unique in its mechanical system as it runs on a chilled beam system. Chilled beam systems include an active chilled beam and a passive chilled beam. The rising room air is filtered through cooling coils and pushed out through the suspended ceiling. The passive chilled beam system is responsible for providing air from the floor. The chilled beam system is more efficient and makes for a more quiet space. The electrical analysis consists of a network of electrical components deployed to supply, transfer, and use electrical power, which allows for lighting and technology throughout the building. The center is very innovative in its electrical components. Most of the lighting through the hallways or main paths of travel line the edges of the suspended ceiling. The lighting within the classrooms and other designated rooms or areas is arranged in a way that lights the space efficiently. In addition to the lighting, the large auditorium has an electrical seating system which seats 250 people and has the ability to retract, completely transforming the space depending on its needs. Lastly, the facility incorporates large electrical interactive touch screens which are appealing and informative. The plumbing throughout the center is a stacked plumbing system similar to what is illustrated in the image on the top left. The stacked drainage systems are generally used in multi-story buildings and can greatly improve the performance of soil and waste drainage systems. Because much less pipe and fittings are needed, less space is needed for piping. In addition to the stacked plumbing system, the fire sprinkler system is also a stacked system. Similar to the image on the top right, the grid-style system also saves space and ensures coverage in the event of a fire. Throughout the center, some of the firehead sprinklers were capped and others were not. This just makes for a more appealing aesthetic when inside the building.